I'm just going to explain the principle of axonometric drawing, and I'm going to use a flat shape made on a rectangle that's 26 squares in length and 16 squares wide. This is a generic shape simply to demonstrate the principle. And in order to make a drawing of it, we would need to skew it at 45 degrees like this, which we will then use as an underlay for a 3D sketch. So this is the same shape, cut out and skewed at 45 degrees, color photocopied, so you don't have to draw it again. I'm going to draw it in 2 layers like a sandwich. So a piece of paper goes over the top and we start to draw these shapes more clearly. Then I'm going to mark the levels of each of the layers. There is 1, 2, 3 levels. And then we're going to physically drop the whole drawing down and start to draw the next level, replicating the shape again just by drawing through and ignoring the drawing that preceded it. And this will give the top layer that's identical to the lower layer. Then we can draw the vertical lines that pull both shapes together to render them in 3D. You can repeat this to get more layers. When you have a sufficient ghost in blue pencil, you can draw it up as a wireframe in pen. I've emphasized the plan now on top of the structure in black pen. And here are some other studies made using the same principle. The drawing exercise that accompanies this film gives you an opportunity to draw a simple massing diagram in axonometric. You are given a plan and a set of shapes that can be drawn as columns to specific vertical heights. If you do the exercise, you will have an intuitive understanding of how to manipulate and configure a set of components as a 3D model. This is the Ordnance Survey map that contains the plan of the University of Kent's Templeman Library, which is the subject of Film 5 in this series. Project architect Susie Winstanley uses the map as an underlay for a massing diagram by first zooming to the site, laying trace over the existing footprint of the building, overlaying a new plan, and then extruding the shape. The drawing is colored in Photoshop and a legend is added, and the simple freehand sketch becomes the focus of a presentation sheet. This is a great practical example of axonometric drawing. It leaves out unnecessary detail to communicate a great deal of information with simplicity and clarity. Axonometric drawings lend themselves well to constructing exploded views. That is, diagrams that explain the organization of interior spaces. This short exercise, which is a study of a generic 2-story house, shows the use of 2 scales of drawing, which are 1 to 100 and 1 to 50, and explains the principles of skewing, then extruding from plans in axonometric. To understand the layout of a floor plan, it's necessary to understand the scale of spaces and how they are determined by human dimensions. A good place to start is with a tape measure in your own home, looking at the size of rooms, stairways, windows, and doorways. This gives you a sense of the minimum dimensions you need to design within for human occupation. Rough studies can still be in scale if you sketch them like these at 1 to 100 on grid paper, where 10 millimeters equal 1 meter. This is the floor plan and elevations of a 10 meter by 6 meter house at 1 to 100 scale. It's deliberately simplified for our purposes. The height of the first floor is shown with the blue horizontal band, and the dotted line indicates the horizontal sections where the house will be separated into floor plans to form an exploded diagram. The initial sketches will be modified as the design of the house changes throughout the project, but at this stage you need to consider where the windows, doors and stairs are, so your very basic plan will show you how you will get into and out of and up and down the house and where light will enter. To make more detailed drawings, particularly of stairs, it's necessary to change scales from 1 to 100 of the first exploratory sketches to 1 to 50. To extrude from the plan, it should be skewed to 45 degrees. Vertical lines are projected from the inside and outside walls to a height of 1200 millimeters. And this is the height that a plan is drawn to in order to indicate the height that windows are fitted at. To calculate the position of the stairs, you need to know what height and length you have to fit them into. In our example, the height and length are both 2,800 millimeters, and each of the steps are 215 millimeters tall, and we fit 13 of them into the space. Drawing the stairs out at 1 to 50 is an excellent exercise, as it helps you calculate their shape in elevation by studying the plan and end view. This 3D view shows how the stairs will fit into the house. The 1.2 meter section height is shown here on the model and in the axonometric sketch. The skewing and extruding exercise is repeated here. This time the first floor level is higher than the bottom line of our section cut. The pitch of the roof is calculated by drawing the basic rectangle that we have from the plan to the required height. Transfer details from the plan and elevation to establish the outer points that our pitch will rise up from. Then measure the height of the pitch using a center line and height taken from the elevation sketch. Finally, join up the points to get the 3D sketch of the roof pitch. Show the final exploded views by lining the floor plans up vertically with sufficient space to allow all views to be seen clearly.